are done, you take those 50 people and count maybe the color of their t-shirts and tell the person who came to us, maybe black has 20, white has 10, yellow has 5, something like that. We tell them, okay, from our system, we recommend black. We've built a recommender system. All we did was to share questionnaires, get how happy people are, and then count the color of their t-shirts. And that's a complete system. That's what happens here. That's what they call recommender system. The weight of the name is heavier than the process.
A whole lot of
that's what it is, right? So,
but these networks, they don't just exist for.
But in e-commerce, right, it's not. It's straightforward, but not exactly what I just said. In e-commerce, we have two kinds of recommender systems. So we have similar items and we have complementary items. Similar items are items that can replace the seed item. Seed item being the item that you click as the user. So you click the item and then recommendations come. So the seed item is that item you click, right? So we have similar items. And then we have complementary items. The complementary items are the items that go with the seed item. Phone, earpiece is a complementary item.
It's too expensive, so they are like a cheaper.
And okay, so if you notice what I said initially, right? I said we check for happiness and then check for color of t-shirts, right? So if you notice, we have two stages. Number one is detect happiness. Number two is count color. So in the industry, we'll call that a 2-pass ranker.
There's actually blockchain.
In your mind, hold it as 2 passes. When I got into the industry, they told me it's 2 pass, 3 pass, 4 pass. So that's what I'm delivering, right? But you can say 2 passes, 3 passes if you want, if you feel that's correct, right? So in the industry, for similar and complementary items, we have 3 passes. We have the recall stage, which is to get items that fit the use case, be it similar or complementary. Then we have the relevance stage. So of the items from pass 1, which items are more likely to be purchased? And then we have the revenue ranking. Of the items from pass 2, which items will generate the most profit? So recall is simply which items fit what we are trying to do. Then when we get those items, which items are more likely to be purchased? Then when we get those ones, which items will give us the most money from these ones? That's what we do, right? So for the recall stage, how do we begin?
But is there anyone here that does not know basic?
So for similar items, we get a bit technical, not too technical, right? You just need to understand the concept and then you can do it yourself. I promise that after this talk, everybody here will feel like they can build recommender systems. I did not say everybody will be able to build recommender systems. I said everybody will feel like they can do it, right? So for the similar items, so we get items, we want to use the item name. So we have iPhone 12, we want to be able to detect iPhone 11, iPhone 13, iPhone 15, and all. So we use the name, right? So for the whole point, what this thing is just talking about is we have items, iPhone, lightning charging cable, wired heads. So we simply separate them into something called a hash map for Python programmers. Please, how many people here are Python programmers?
Solve that problem for you.
Okay, lots of people. How many people don't program at all? You don't code at all?
Whereby
okay, you don't code at all. Okay, so the whole point behind what we are doing is to separate each word in the name, right? When we separate each word in the name, we detect how many items have those words in their names. That way we get them. Does that make sense, please? So that way we get them, and then we use something called a TF-IDF. For, I think people that have gotten into NLP a bit may know what the TF-IDF is. So time frequency index inverse document frequency. What we're basically saying is how important is this word in the name. We get that, and so TF-IDF is like a score. We attach these scores to the items. Once we have attached these scores, we then rank them and pick, let's say, top 200 or top 100 or top whatever you want. That's the first stage. We call that the recall for similar items. But for complementary items, it's a bit different. So for complementary items, for similar items, we don't just use the name, right? Because if we use just the names, maybe for iPhone 11, we may end up recommending just iPhone 12, iPhone 13, iPhone this, iPhone that. We also want to be able to recommend Android and maybe Google Pixel or this. So we don't just use the names, we also use the features. So proximity, ambient light sensor, and all, right? But for complementary items, we're looking for correlation, right? We're looking for correlation, items that correlate. People that bought this also bought this. So it's a kind of collaborative filtering. But I don't want to go into the detail, right? If you want the detail of this, please, you can. The slide is going to be very, very available, so you can go into that. So at the end of the similar and complementary item stage, we pick our maybe top 200 or top 100. So we get our item. So this is similar to the happiness stage, right? Happiness, where we attach happiness score. So this one, the score we are attaching is TF-IDF for similar items, but for this one is count, right? So people that bought iPhone 13 also bought iPhone charger, they bought iPhone earphones and Apple Watch. So together, right? Co-purchase or co-view, co-search, we use these things. And then at the end of the day, you have your top whatever items you want. So we get our similar and our complementary items. So at this point, we want to answer the question. So of these items we have gotten, which items are more likely to be purchased, right? Now this is where the whole machine learning comes in. People that build models, Zindi, Kaggle, feature engineering, feature selection. It's at this point that it comes in, right? So what we want to do here is we want to predict a score. This is a classification problem, but it did not, let me say, finish school. It dropped out in final year or so. Now, why? Because, so when you're doing classification, you're actually predicting scores, right? When you're done predicting scores, you then use something like a softmax function to turn the scores into classes. So at this point, for us, we're not turning the scores into classes. Since it's the scores we're interested in, we're trying to rank them. So when you're done making your predictions, your ensemble models, please don't use ensemble in production. It does not work. Very slow, right? So we make our predictions. So purchase is class 1. We're trying to detect purchase and no purchase. Right. I feel like this talk is too technical. Is it too technical, please? It's too technical, right? Okay, I will not go into the technical detail again. So the point is that... Sorry, are you...
The query part is what I showed us earlier when you go to studio. So yeah, display will be just on this monthly scale.
Please, we'll okay, double time for questions, please. I'll answer that. Okay, so at the end of the first stage, we get which items that are relevant. At the end of the second stage, we get which items are more likely to be purchased. That is the summary of the first two stages. Right. Then for the third stage, we're very interested in making money, right? Nobody's interested in just, okay, some people are actually interested in the machine learning itself, but the business owner, so I'll tell you a short story. So when I was presenting to the decision makers of eBay one time, I realized that all of them on the Slack channel were just quiet. So I was talking and nobody was responding at all. So my boss DM'd me and was like, see, just tell them how much money we are likely to make. And I then switched and said, okay, if we're going to make this, we've A/B tested it, revenue increased. And everybody started posting fire chats on the Slack channel. I was like, okay, it's like maybe what I was saying initially. I was not communicating. Right? So everybody wants to make money, even Igalo. right? Igalo said that we should build recommender systems for money and not passion, right? So that's the insight I got from him, and that's what we want to do. So when we get our items using the score, we don't just rank them based on the score. We multiply the scores by the revenue that we're likely to make from it. Why? Because if an item has an 80% probability of being purchased and it is worth $100,000, is a lot more important than an item that has a 99% probability of being purchased, but is worth only $10. It's better for us to display the more costly item first, right? So we multiply them, and then that's our final display strategy. So we have 3 strategies: which items are relevant. Then number 2, of the items that are relevant, which ones are more likely to be purchased, and of the items that are more likely to be purchased, which ones will give us the most profit. Those are the 3 strategies, the 3 stages we use for building recommender systems in e-commerce. Like, just as for recommending the t-shirts, we use which people are happy, then which t-shirts are they putting on. So for e-commerce, this is what we use. Further note, if that side was technical, then I won't go into this side, right? Because it's a lot more, right? So that is how we build recommender systems for e-commerce. Please, does anybody have any question at this point?
There's a whole lot that could happen in SQL.
Yes, your question.
Let's just leave it as this. But yeah, next slide.
That's something that can be solved by better. Is that something that can be solved by better hardware? Because like now, when NVIDIA presented, they do solutions for things like that.
Okay, so his question was that I said ensemble methods are slow. Is that something that can be solved by better hardware? The answer is yes. The answer is yes, you can solve anything by better hardware. But the thing we're interested in something called latency. Right? Latency is how fast the request will go to the server and return. Right? So yes, we can buy better hardware to solve this problem, but how much hardware do we want to keep adding? Right? We don't want a situation whereby if you ensemble models together, you may get performance of 90%, but the hardware you bought costs about $1 million. But if we do not buy that hardware, we'll get a performance of about 85%, and we've saved $1 million. Now, 85% and 90%, there's no much difference. The performance is still good, but we have saved $1 million. So that's why we do not do ensembling in production. It's not that we cannot, we can. Better hardware will solve the problem, but at what cost? That's the answer.
Okay. And if you're trying to foray into this.
Yeah, so thank you. You were talking about like 2 types of recommender system. You said the similar and the complementary. Okay, now for someone that is just starting, like maybe I'm building an e-commerce website now, and nobody has purchased like some of my product before, like iPhone. Maybe they now purchased a charger. Like, I want to ask her, like, can you tell us when to use when out of all those 2 types of recommender system, and which is more used in them?
It goes deeper.
Okay, so how do we heard him, please? Okay, so his question was, when we are just starting, which of the 2 types between similar items and complementary items should we use? Is that the question? Okay, so the answer is that it depends, right? So normally similar items give a lot more money than complementary items, because similar items can replace the item you're trying to buy, but complementary will just be something like maybe earpiece or charger, right? So similar items actually give more money. And if nobody has purchased, to make recommendations, you can simply ask questions. So all these questionnaires you get on websites, so rate this product, do you like this product? Those kind of things. You can just ask questions instead of having to go through the machine learning process. But when you have when you have customers that have made purchases, then you can implement this. Does that answer your question?
Something that can actually solve a problem. In this,
I have two questions actually. First is your search functions. I saw some functions you displayed on the slides. Do you write them during production? Do you write them yourself? Like, is it the job of the ML engineer to write it?
they will call it the.
Okay, so is that
I mean, NFT project, there were a lot
And
of
the second one,
NFT projects
the target
that eventually come
variable
up with a
for
project
the
that actually
data frame you showed us.
to see the time that
Which kind of modeling is that? Because it looks like a multi-class
you need to see
model.
how
At the same time,
consumers
it's
have reacted to
it solves regression problems to
Like,
get
if I
those
drop the same
class. I don't know
they
if
react well to it. That's what
okay? So his first question was,
I would present to you.
sorry, what was your first question?
So, transactional
do you write
analysis is
the
very,
search
very
function?
important.
Okay, do I write the search functions? I told you I like to laugh, right? So
Where you are
is that laughing? No, it's not laughing. Okay, so
going to be
do I write the search functions myself? No, we do not do that. So, okay, we do not write the store ourselves, right? But there is a stage, it's a pipeline. This whole thing is a pipeline, right? So there's a stage in the pipeline that has these
analysis.
functions, right? And they run on high-level languages. Like,
Able to say that.
they run on really performant languages like Java and also that they are fast. So yes, the algorithm for the TF-IDF and looking for
Whereby
what you're asking me is systems design, basically. So for looking for the items and then performing the search, there's actually a stage for that. We also cache some of these items. We also do distributed search. So what you're asking me, what you're asking me is systems design. But yes, that is what we do. Then for the second question is what we predicted. Yes, it's a multi-class.
platforms that I displayed earlier, you just SQL that you need. But if you want to become a Python
Are
person
looking
or
like
whatever,
regression-based obtained values.
help you out with this.
I don't know if
so
you
it's
can
not
go back.
limited to SQL. So performing,
So you mean here, right?
exploring DeFi protocols and all that, you need to perform analysis. If I wanted to,
Are they because I'm seeing floats? Are they regression-based obtained values?
was for me to invest.
Okay. So he's asking that since these are classes,
And if
why are we getting regression values instead of classes?
that's
Is that the
where
question?
you are required
Okay.
because
So like I said earlier, what is a classification problem in machine learning, first of all? Right? So a classification problem is simply a regression problem that is classified.
you need to know
When you build models, right, when you want to make your predictions, you write dot predict, maybe using random forest or XGBoost or something. You write dot predict. But there's another method called dot predict proba.
so
Predict underscore proba, right? So that's predict probability. So that one will give you the actual probabilities before it is then capped using something maybe like a softmax or maximum or whatever to turn it into classification, right? But so at that point, we are not turning anything into classification. We are going to keep the scores like that. So those scores there are the probability of each class. Yes, those are the predict proba, exactly. Sorry, somebody asked the question. Let me just.
that even come after polygon, something like arbitrary.
Hi, good afternoon. I'm trying to, this is, from where this is all data science, machine learning. So I'm not trying to talk about the technicalities here. I mean, this mic's working. You once spoke about like the latency involved, because I would like to plug myself into how I can fit into this business structure as a data engineer. So isn't everything, when you try to talk about this, similarities and classification, doesn't everything stem up from what exactly the data says before you guys now start saying, okay, I want to build the whole classification systems? Isn't it meant to be like, okay, what exactly is the need right now for eBay? I'm just trying to imagine before you now start saying, oh, whether or not we can use classification systems on this or that. I was just trying to imagine.
We need blockchain data in.
Okay, so his question is that
My recommendation.
are we supposed to ask what exactly we need first of all before building this? Is that your question? Okay, so I did not. I was not there when they started eBay, right? I joined, right? So these decisions must have been made, but it has been defined that we have recommender systems, similar items and complementary items. They are a standard there. We are simply just building. Does that answer your question?
You see their website, like whatever you want to do. They just
Okay, so I wanted to ask a question about how to get started, but you already did. So I wanted to know, as regards the storage now for these similarities and everything, how are they stored on the back end? And also, like, how do you update them when you have new customers, purchasing things to like now update the database for new customers to like have more things?
To get this,
so
you can see
these recommendations are actually personalized, right? We don't store a particular recommendation like impressions, called an impression. We don't store a particular recommendation for.
Joining a community like this, you can easily
has ranked something or has an interest in something, I am maybe doing the comparison for other customers. Like, do you update as new customers prefer this? So let's say I prefer this now. Do you add that to the database of what you're going to compare for the next person?
Okay, let's say his question is that, let's say a customer prefers something. Do we add it to the recommendation of another customer? Okay, so what you're asking for is collaborative filtering. So I mentioned that the complementary items, we use collaborative filtering. So if you look at this part, I said something about co-purchase. How do we know if a customer likes something? So we don't just use co-purchase, we actually use co-search, co-viewed, or rated highly, right? So if a customer actually purchases, let me use purchase in this case, purchases something else, right? We count all customers that have purchased that item, right? So when we mean co-purchase, we mean you purchase both phone and charger together. So everybody that has purchased that phone, a new customer is trying to purchase. So we check what they purchased alongside the phone, and then that is what we take through the complementary items stage. Does that answer your question, please? Sorry, there was one more person. Oh, I'm not sure.
Okay.
All right, good afternoon. So I have a son, he likes Roblox like you, and he likes animation, he likes stuff like this. What are the skills to go into your field, and what are the courses to take? Thank you.
Okay, skills. Okay, the skills to take are, so I first started as a software engineer. Right? So I used to just build websites before moving into machine learning. So I'll say the skills you need. If you were here yesterday, there was a speaker, Temi, that broke down what we need. So the things you need, you just need a little bit of math, not too much, a little bit of mathematics, and then programming skills, and then an understanding of the algorithms. That's what we need. There was one person here that wanted to ask a question. Okay, so one last person, please.
You can probably earn 100 USD. So that's one. And secondly, there are also job opportunities. People are looking for blockchain.
How do you evaluate recommender system? How do you evaluate recommender system?
Okay, how do we evaluate recommender systems? So we have something called NDCG, non-discount count gain, but that's offline. We have two types of evaluation, offline and online. Online, we just use purchase. Was it purchased? Yes or no? That's how we evaluate it to know if your model was good or not. But offline, we use NDCG. It's also a ranking metric. Non-NDCG, non-discount count gain. So that's what we use. Thank you very much.